Good morning, friends. In this class, we are going to discuss in detail about power transmissions and the designs in mechatronics. So, myself, Professor Ganesh, working as assistant professor in Department of Mechatronics Engineering, KRSO College of Engineering. So, going into the details, these are the power transmission methods, which are most of the mechanical background people will understand easily. So, which is the first one is gear train, which is used in automobiles and engines. You might have seen gearboxes in cars and higher-end vehicles. So that is the first type. The second type is chain drive. Chain drive, you would have seen chains in motorcycles and bicycles to drive the vehicles. The next one is belt drive. Belt drive is rice mills and sewing machine. You would have seen in rice mills in childhood. We would have seen in when we would have gone to rice mills. You would have seen a bigger pulley driving a smaller pulley. So in sewing machines also we would have seen. And then the last comes rope drive, which can be seen in lift and cranes. So the first type in our syllabus is belt drive. So belt drive consists of two pulleys. The first one, pulley, and motor drive. Motor drive can be basically a pulley which can be connected to a motor, maybe a DC motor or a servo motor, depends on the application, and which drives the driven pulley in which the load is being connected. So in here a load can be connected. Here a load can be connected. Maybe a roller or something, or a grinding machine or something. Here a motor will be connected. So this would be a motor. Supply will be given. Okay. So the thing is that the driving and the driven pulley will be rotating in the same direction. Okay. So this is the schematic diagram of belt drive. Okay. Next we are going into the applications. The main applications we are seen in robotics and automation is like conveyors. So thermal power plants would have seen coal handling conveyors on which the coal goes to from the port to the boiling boiler in thermal power plants. So the first application here, this is an idler pulley. The middle one, you can see an idler pulley, and supported by many other pulleys. Okay. The second application is a rice mill, which most of us would have seen. The rice mill, so which consists of a motor which drives all the. So this is a motor. So this drives this mechanism, which is connected to a belt, and which is connected to a grinding machine. So everything is connected in a parallel shaft, in the same shaft. Okay. Next. Okay. Then the next comes application is sewing machine. So sewing machine, here you can see belt, drive belt, which is connected to a motor, and the bigger part of the or the bigger pulley is connected to a shaft or the hand wheel. Okay. The next one is the timing belt in the engine. So many would have seen timing belt in the engine. Okay. Then the next application is 3D printer. 3D printer is a mechatronics application. So here you can see a pulley which is connected by a belt. So actually there will be 3 pulleys for X, Y, and Z direction. Okay. The next one is a mobile robot. So in this mobile robot, both the wheels are connected through mm, through this is the belt. So as you can see, this is the belt, and here a particular motor is connected, and to give this drive to the another wheel, we are using a belt here. Okay. Okay. Now you can see there are many applications in mechatronics, related to mechatronics, where we can use belt and pulley mechanism. Okay, like coordinate measuring machines, and many other machines. Okay. Okay. Amount of power transmitted by belt depends on. So what is the power transmitted through belt? So they depend on the velocity of the belt, the tension of the belt, arc of contact between the belt and the smaller pulley, and the condition under which the belt is used. Normally, if it is used in rainy conditions, or like oily, if the oil between, or if the friction between the pulley and the belt is less, it may cause slippages. So those conditions are also considered. Okay, belt type. So it is a flat belt type. So the central thing is a V type belt type. So the last one is the round belt. So depending on the applications, you can use any type of belt you prefer. Okay. So normally belt type, this flat belt type is used. And the V belt and circle belt depends on the load and the friction. You can use V belt and circle belt. Normally V belt is more advantageous than flat belt. Okay. Next, belt material. So you can use any of these belt materials, like leather belts, cotton or fabric belts, rubber belts, and balata belts. Okay. Next, belt type, drive belt type. So normally these are the drive belt types. So open belt drive, closed belt drive with idle pulleys, compound belt drive, and stepped or cone pulley drive. Okay. Open belt drive. So open belt drive is used with the shafts arranged parallel and rotating in the same direction. This is a normal type you would have seen in many part. So this is a pulley, and where the shaft would be like this, and here is the shaft. So these two shafts are in parallel. Okay. So and rotating in the same direction. Okay. So this is rotating in this direction. So this is rotating in the same direction. Okay. Right. So normally this would be the tight side, and this would be the slack side. So as the driver rotates like this would be the tight side. Drags load to this direction. Okay, and this is the top view of that. So top view. So here you can see this is the shaft. This is also a shaft. Okay, right. Then close belt drive. Close belt drive is used with shafts arranged in parallel. So here also you can see the both the shafts are arranged in parallel and rotating in opposite direction. Suppose we need to rotate the driven pulley in opposite direction, you can use in this mode. Okay, right. With idler pulleys. So this is used when the friction in between of the pulley is less, smaller pulley is less, or otherwise the angle of contact is less. Okay. So ideal pulley is pulley which does not transmit power but assists power transmission by increasing angle of contact of smaller pulley. You can see here. So this is an ideal pulley. So okay. So this is an ideal pulley. So it does not transmit power, but as you can see, if the ideal pulley is not there, it would be the pulley, the belt would be hanging like this, right? So to make the friction more and to make the angle of contact bigger, so we are using idler pulleys. Okay, so you can see here, these are the idler pulleys, right? These are driven pulleys and this is the driver, right? Next is compound belt drive. Compound belt drive, you can power is transmitted via series connected pulleys in a shaft. Okay, you may ask why there's a compound belt drive. So here you can see, as you can see, this is the bigger pulley, right? This is the bigger pulley, bigger pulley, bigger, and this is smaller. So here this is bigger and this is smaller. So normally if you have to increase the speed or you have to decrease the speed, so you can use this uh, type of compound belt drive. Okay, right. So how would you increase the speed? So it's like if this bigger pulley is like double the size of this smaller pulley. So if it rotates if this one rotates one revolution, this one rotates two revolutions, okay, per second or per minute or something, any definition of unit, right? Okay, so this is stepped or cone pulley drive. So cone pulley drive, it is used for changing the speed of the driving shaft while main shaft runs at a constant speed. So this one main or driving shaft, this one is driven shaft. So this would be running at a driving shaft would be running at a constant speed. So if you have to change the speed according to your desired application, you can change the cone pulley of the driven shaft. Okay, so it's like a gear changing mechanism uh, in a serious connection, right? So these are the built drive selection criteria. So speed of driving and driven shafts, and so power to be transmitted, positive drive requirements, space available, speed reduction ratio, center distance between the shafts layout, and the service conditions. Selection criteria. Okay, parameters to be considered for design: length of the pulley, drive contact angle, speed of the driving motor, and maximum load to be driven. These are the parameters should be considered for a particular application. So it is the formula to calculate the length of the open belt drive. So this is a bigger pulley, and this is a smaller pulley. So to calculate the belt length of the open belt drive, you can use this formula, so where pi r represents this represents the distance between radius of the bigger pulley, and x represents the distance between the center points. These are the center points. So x represents the distance and r2 represents the radius of the smaller pulley. Then angle. So angle, where the belt is connected, so the force vector would be in this direction. Okay, so that's why we are taking this line and the center of this pulley. Okay, so the angle between these two, so this angle, if we consider this triangle, this angle is this alpha, r1 minus r2 divided by x. Okay, right. Then the relation between maximum tension and strength of the belt. So what is the relation between maximum tension and strength of the belt? So actually it depends on the maximum tension in the belt. T is equal to the total tension of the tight side of the belt. Okay, so T is equal to maximum stress in the cross section area of the belt. So width of the belt into thickness of the belt. we give a cross section area, and then you can find the maximum stress. Into maximum stress, you will get maximum tension in the belt. Okay. Next, power transmitted through the belt. Power transmits tension in the tight side of the belt in newtons, tension in the slack side of the belt in newtons, and velocity of the belt. Okay, so if we calculate, we will get the power T1 minus T2, or tension into velocity. We are getting power. Fine. In the next lecture, we will see how to calculate the torque, maximum torque required to lift a particular payload, and we will look into some problems.